I greet you all. So this is Mugomba Ronald, MBCHB, back again. Welcome to my YouTube channel, Medicine Made Easy, Medical School Made Easy. We are continuing with nerve muscle physiology, MCQs. Consider to subscribe to the YouTube channel. Consider to like, drop in a comment, and share the video to the other people. You can freely share so that we are able to give you more and more publications. So we are continuing with nerve muscle MCQs. Now, the last time in part 2 we were looking at 223 and we ended as an alternative C. Now we are going to 223 in part 3. This is part 3. So if you have not watched part 1 and part 2, consider to go ahead and first watch part 1 and part 2. Then you can go ahead. You will enjoy more part 3. So part 3 we begin from 234, which says about release of calcium ions to the to action potentials. All the following is true except A. Calcium entry takes place in the late phase through the slow calcium channels. B. Calcium entry takes place in the late phase through the fast sodium calcium channels. C. Increase in calcium concentration decreases the membrane excitability. D. Decreased calcium concentration increases the membrane excitability. Okay, so those are the alternatives that we have for 2, 3, 4. Let's think about the correct answer, the incorrect statement. The incorrect statement is B. Calcium entry takes place in the late phase of the late phase through the fast sodium channels. That is the incorrect statement. The other statements are all correct. Calcium entry takes place in the late phase through slow calcium channels. That is correct. B is incorrect. C is correct. Increased calcium concentration decreases the membrane excitability, as we saw previously. D is as well correct. Decreased calcium concentration increases the membrane excitability. So the incorrect statement here that we have is B. Now, to be specific, for instance, increased concentration, calcium ion concentration in the ECF is the one that reduces membrane excitability, and decreased still calcium concentration increases membrane excitability still. Okay. So we can go to number 235, which says we can go ahead and look at 235. Says about types of nerve fibers, all the following is true except type A fibers. Type A fiber have largest diameter, have largest diameter and most rapid conduction velocity. B. We are looking out for the incorrect statement. B. The preganglionic autonomic nerves belong to type B. C. The type C fibers have the smallest diameter and lowest conduction velocity. D. The postganglionic autonomic nerve fibers belong to type C. E. The type A fibers have a spike duration longer than the type B fibers. We are looking for the incorrect statement for 235. So 235, the incorrect statement is E. The incorrect statement for type E, for that statement is E. Type A fibers have a spike duration longer than type B. That is wrong. The inverse is true. That type B usually have a longer duration than type A. The other alternatives are correct. Type A fibers have a larger diameter and more rapid conduction velocity than type B. That is correct. The larger the diameter, the faster the transmission of nerve impulses, because that provides a larger surface area for exchange of ions. The preganglionic autonomic nerves belong to type B. That is correct. Type C fibers have the smallest diameter and lowest conduction velocity. That is correct. The postganglionic autonomic nerves belong to type C. That is also correct. So the incorrect statement is E. We go to 236. Concerning the oxygen date mechanism, it is the oxygen supply to the of the basal oxygen consumption. B. It involves oxygen consumption during muscular activity. C. Athletes develop a greater oxygen date during a given exercise than sedentary people. D. It is used to remove excess lactic acid and replenish the ATP and creatine phosphate stores. So the most correct answer is D. D is the most correct answer. Oxygen date is simply that additional amount of oxygen that a person breathes in after an exercise. That explains why the breathing rate of a person after the exercise does not decrease back to normal. It remains high. To supply that additional amount of oxygen that is going to be used to break down lactic acid and even replenish ATP and the phosphocreatine stores that were used up during the process of activity. It is incorrect to say that it is used to supply used for supply of basal oxygen consumption. It is incorrect to say that it involves oxygen consumed during muscular activity. That is incorrect. It is during, now the person is at rest now. Athletes develop a relatively lower oxygen date because their muscles are trained than sedentary people. That is also incorrect. So the correct answer is D. In skeletal muscles, the transverse tubules of adjacent cisterna constitute A. a triad, B. sarcolemma, C. myofibril, D. muscle fiber, E. sarcomere. I can see most of you are saying that we are on 237. Triad. A triad is simply a word that we usually use to mean transverse tubules, a transverse tubule in between two adjacent cisterna or two adjacent sarcoplasmic reticula between two different areas or two adjacent cisterna. That combination of two adjacent cisterna on either sides of the transverse tubule, that's what we call the triad. A sarcolemma is simply the nerve, the membrane of the nerve. The sarcomere is the functional unit of the nerve fiber. The nerve fiber is that elongated cell, muscle cell. Sorry, sarcolemma is muscle membrane, muscle fiber membrane. The sarcomere is the functional unit. Myofibrils are those myosin and actin, those small fibrils that are found within the muscle fiber. So the correct answer here is A. The maximal tension is developed 236, 238. The maximal tension is developed in a skeletal muscle when they are at A. equilibrium length, B. resting length, C. more than the resting length, D. 3 times the equilibrium length. We are looking out for the most correct answer. Maximal length is developed in a skeletal muscle when they are at, the most correct answer is B. resting length. Maximal tension is that maximum tension that the muscle can have. So for a muscle to attain its maximal tension, it will, for instance, if the contraction begins from the resting length, it will be able to give us the maximal tension. That maximum tension, the maximum force that the muscle can exert or it can form, it will be greatest when the muscle begins from the resting length. We go to 236, 239. Immediate source of energy in the muscle contracting is in the form of A. glucose, B. glycogen, C. protein derivatives, D. free fatty acids. The most correct answer is sorry, the most correct answer is phosphate derivatives. In fact, it is in the order of ATP, that is say adenosine triphosphate, that's a derivative of phosphate, and then 2, after ADP is done, we start deriving energy from phosphocreatine. When phosphocreatine is done, we go to glucose. When glucose is done, we can go to glycogen. When glycogen is done, then we can resort to free fatty acids. So the most correct answer is C. We go to 240. All the following are effects of denervation of skeletal muscles except A, atrophy of the muscle, B, hypersensitivity to saturating acetylcholine, C, muscle fibrillation, D, muscle fasciculation. The correct answer there is D, muscle fasciculation. Muscle fasciculation is the correct answer. It is not true for when you denervate a muscle, it cannot form new fascicles. Instead, it loses the fibrils. So, muscle fibrillation is correct. Hypersensitivity to saturating acetylcholine is correct. And the muscle becomes atrophied. It becomes smaller in size. The muscle becomes far much more sensitive to any saturating acetylcholine. The muscle loses its normal fibrillation. Muscle fibrillation takes place, atrophy takes place, the muscle becomes very small in size, but muscle fasciculation does not take place in a denervated skeletal muscle. It's like when people go to the gym, that is the muscle, the fascicles will increase in number or in size. So that cannot happen when the muscle has been denervated. Now, we can go, so the correct answer for 240 is D. We go to the next question. The first type of muscles is characterized by all the following except first type of muscles is characterized by all the following except a high ATPase activity in mitochondria, specialization for posture maintenance, innervation by large motor neurons, in brackets alpha fibers that conduct at a velocity of 70 to 160 meters per second. D, rapid fatigue. E, absence of myoglobin. So we are looking out for the incorrect statement concerning first type muscles, or sometimes they are called the white fibers. We are on 241, and the correct answer is B. The incorrect statement is B. Specialization for posture. White fibers are not specialized for posture. They are specialized for movement, rapid movement, fast. So they are characterized by high ATPase activity. They are characterized by innervation by large neurons. They are characterized by rapid fatigue, and they are characterized by absence of myoglobin. Myoglobin is that red pigment that is very important for storage of oxygen. So first type muscles are sometimes called the rapid oxidation muscles, and sometimes are called the white fibers. They are more a muscle. The function of the muscle usually determines the proportion of fast fibers or slow fibers. So when a muscle is so much active, like in the in the splinters usually have a higher proportion of fast type muscles. They cannot tolerate long distance running because they have a shortage of myoglobin, and their muscles can easily get fatigued, especially the ones that are involved in running. So long distance runners have a higher proportion of slow type muscles, or slow twitch muscles, or what they call the red fibers, which have a relatively higher myoglobin concentration, less fatigue rate, and and are innervated by smaller motor fibers, and they are very important. They have lower ATPase activity. Okay, we can go ahead to look at 242. In plain muscles, ig in the intestines, that is gastrointestinal tract. A, contraction is dependent on nerve supply. B, resting potential is high. C, calcium is involved in initiation of the contraction. D, epinephrine decreases the membrane potential and increases the frequency of the spikes. E, catecholamines cause muscle contraction. We are looking out for the correct statement. 242. C is the most correct statement, which says calcium ions are involved in initiation of contraction. We know that calcium ions usually leak into the membrane, and that is through the leaky calcium channels. So when calcium ions leak into the sarcoplasm, that initiates the opening of the calcium voltage gated channels. When the calcium voltage gated channels finally open, then we can see influx of calcium ions much more greater, that will be higher enough to cause formation of an action potential. The other are not correct. Contraction is dependent on nerve supply. That is not correct. Sometimes they can undergo myogenic stimulation. Sometimes it can be stimulation by hormones like epinephrine or norepinephrine. Sometimes it can be by chemicals like histamines, can cause their contraction. And it is incorrect that their resting membrane potential is higher. It is not correct for you to say that epinephrine decreases their membrane potential. In fact, it increases it. It is not correct that it is not correct that catecholamines cause muscle contraction in this context. So the most correct answer is C. 243. Decreasing the sodium concentration around a nerve. A, decreases the resting membrane potential. B, increases the overshoot. C, increases the chronax. D, decreases the action potential. We are on 243. The most correct answer is D, decreases the action potential. Now, when you say decreases the action, when you decrease sodium ion concentration around a nerve, you will decrease the action potential. That means that when the sodium ion concentration outside is far much less, that means that we shall have less sodium to get into the membrane when finally we see opening of the to get across the membrane into the sarcoplasm. Because when you to get into the exoplasm, because usually that's what happens after the sodium voltage gated channels open. So when you have less sodium to get inside, that will reduce the action potential. The others are not correct. Increase in overshoot, that's not correct. Overshoot will have to decrease because sodium will move by diffusion through the voltage gated ion channel. So if it is reducing where it is coming from, that is to say the ECF. So if the ECF it is less, that means that less will go into the ICF, and that will lower the action potential. 244. In isometric contraction, the initial heat is, I think we have talked about it, we talked about it in part 2, is too small to measure. B, approximately equal to the activation heat. C, equal to the shortening heat. D, more than relaxation heat. We said initiation heat is what is the most correct answer? In isometric contractions, they say isometric contractions are contractions that are involved in increase in tension but do not show any changes in length. Like for instance, you are pushing against a stationary object or a fixed object. Okay, the most correct answer is B, is approximately equal to the activation heat. It is not true that it is too small to measure, otherwise we wouldn't have it anywhere. It is not true that it is equal to the shortening heat, it is not true that it is more than the relaxation heat. Okay, we can move on. So the most correct answer is B. We can move on to the following characteristics are present in both skeletal muscles and smooth muscles. The myofibrils both have Z membranes. B. Both initiate spontaneous rhythmic contractions. Both contain actin and myosin and show tone or contraction at rest. D. Both can be affected by hormones and chemicals equally. 245. We are looking at something that is common for skeletal and smooth. The most correct answer is C. Both contain actin and myosin and show tone or partial contractions at rest. That is correct, and it is the one that is responsible for the resting heat we had talked about earlier. It is not true smooth muscles do not contain Z membranes, and it is not true that skeletal muscles show spontaneous rhythmicity. That one is restricted to smooth muscles and cardiac muscles. It is not true that they can be affected by hormones and chemicals equally. Smooth muscles are more affected by hormones and chemicals. They are more sensitive to them than the skeletal muscles. So, the most correct answer for 245 is C. Now, that takes us to our next question. The local response, 246, the local response is in a single nerve fiber is A. Is produced by cathode current of threshold intensity. B. Associated with increased potassium permeability. C. Is not dependent on the intensity of the stimulus. D. Can produce an action potential of membrane can produce an action potential if the membrane potential reaches negative 55 millivolts. So what is the correct answer? The correct answer is D. Can produce an action potential if the membrane potential reaches the threshold, which is the threshold intensity, which is a threshold voltage, which is negative 55 millivolts. That is correct. The others are not correct. That it is produced when the cathode current reaches the threshold intensity, that's not correct. We look at the threshold stimulus, threshold voltage, which is negative 55 millivolts, is associated with increased permeability, potassium permeability. No, is not dependent on the intensity of the stimulus. It is dependent. That is not correct. So the correct answer here is D. Concerning sodium pump, it requires high amounts of high energy phosphate bonds. B. It is pumping sodium from the outside to the inside of the cell. C. Is explained by facilitated diffusion. D. Is independent on potassium influx. E. Is dependent on the extracellular sodium concentration. 247. The most correct answer is A. Why? Because it involves in the sodium pump involves actively pumping sodium ions from a region where they are least concentrated, that is to say in the ICF, to a region where they are more concentrated, that is to say in the ECF. So that makes B wrong, that makes C wrong, and D wrong, and E wrong. And we only remain with A as the most correct alternative because it involves the splitting of ATP to ADP and an inorganic phosphate, which releases energy that is required to drive the pump. And that takes us to number 2. So the correct answer is A. That takes us to 248. In skeletal muscles, there is an inverse relationship between we can go ahead and look at A. That is the muscle length and force. There is a relationship between A, the muscle length and force for contraction. B, the muscle opposing the contraction and the velocity of contraction. B, the load opposing the contraction and the velocity of contraction. C, the cross-sectional area and strength of the muscle. D, all the above. So the most correct answer here is B. The most correct answer is B. That is, say, the load opposing the contraction and the velocity of the contraction. The load opposing the contraction and the velocity of contraction. Usually, there is a relationship between that. Usually, when the load opposing the contraction is high, for instance, let's say you are trying to raise a 50 kilogram mass, probably a dumbbell or something like a sack. The rate at which you raise it will be lower. It's kind of inverse proportionality. The higher the opposing load, the lesser the velocity, and that makes C be the correct answer, and the others are not correct. Okay, a series of thank you so much for listening. I remain